Good morning, everyone. My name is Abdul Shakir, and I am a research assistant at the University of Sharjah. And it's a pleasure to, present our research on the web-based security assessment of the open source CAD tools. The work is also, co-authored by my professor and colleague, Dr. Mantha, who is an assistant professor at the University of Sharjah. And basically, this study lies at the intersection of construction engineering design and cybersecurity, two of the domains that are becoming increasingly sort of intertwined, especially as they adopt more digital tools. That's what we have seen in this conference as well, and along with construction, the manufacturing processes as well. To begin with, it's important to understand the foundational role that CAD tools play in this era, especially with the additive manufacturing or the AM processes. These tools are used for designing and verifying 3D models and are essential across industries such as civil engineering, architecture, construction, and product design. As their adoption has also increased, especially among SMEs and individual users, we are also seeing a parallel rise in security concerns. So most notably, this particular research is focusing on the download and the installation phase of these tools and presents a vulnerable entry point of cyber attacks. So basically, the AM processes itself consists of 5 critical phases. It has the CAD phase and then the finite element phase, or the FEA analysis. Then we have something called slicing, and then printing, and then finally the assembly section comes into the play. But however, this study focuses only on the CAD phase, and it's very basically the first step, and thus it's a very critical security checkpoint to assess as well. Now that we understand the importance of CAD tools in the AM processes, let's look at some of the cybersecurity risks that are exposed, especially when these tools are downloaded and used on personal or organizational devices itself. So I'm not sort of limiting, but the 4 most important security risks that can come into the picture is first one being the malware insertion risks, which often occurs during the download phase. So users may unknowingly install or download the compromised versions of the CAD tools that contain malicious code. We then have a DOS attack, denial of service, that can target the websites hosting this CAD tools itself. So this makes the platform unavailable to legitimate users at critical project phases as well. We then have the most famous social engineering attacks, when attackers trick users, especially non-technical users who are not that much tech savvy, into disclosing credentials of the CAD design itself, credentials, or even sort of downloading harmful files into their system. Lastly, we also have ransomware attacks, and that's one of the growing threats in this scenario, where CAD files, often proprietary, are encrypted or locked, with attackers demanding payment to restore the access itself. So our research aims to assess the security of open source CAD tools used in additive manufacturing industry. So these tools are quite popular, especially in industries related to AECO, so architecture and engineering construction. So basically what we have done is to identify those vulnerabilities. We have used OWASP ZAP. It's a well-known web-based vulnerability scanner that simulates real cyber attacks on running application itself. So in our paper, we have also outlined the typical user journey. And as you can see in the slide, from exploring a CAD tool website to downloading the software alongside a potential attacker's perspective as well. So this helps us pinpoint where vulnerabilities exist during the download and web interaction phases as well. So basically, by focusing on this user journey, we can better target our security assessment and provide actionable insights to improve safety for all CAD tool users. This is our methodology, which follows a 9-step process designed specifically for web-based security assessment of CAD tools. We began by carefully selecting relevant CAD tools that are widely used in the AECO industry itself. And for vulnerability scanning, we used a technique called DAST, that's called Dynamic Application Security Testing, which tests the application while it's during the runtime itself. And the tool that we use is OWASP ZAP, as I mentioned. So this is the scanning tool. Due to its strong community support and extensive features, this particular scanner was predominantly used. To avoid any potential disruption to the live system, so all scans that were performed of those 5 CAD tools were conducted in passive mode, which pretty much means that scanner observes without actually injecting or sort of disrupting any sort of real life operation itself. We then identified key URLs of each CAD tools, comprehensively covering the attack surface. All right, so the 5 CAD tools that we have used is FreeCAD, OpenSCAD, Blender, LibraryCAD, and SolverSpace. So all these tools have web-based components or websites from which users download the software, making them relevant targets for security assessment itself. All right, the results that we have is a total of 54 vulnerabilities across the 5 CAD tools, with 25 being very unique, of all those 5 CAD tools that were performed. They were categorized by 4 different severity levels. So you have informational, low, medium, and high risks that is used by the OWASP ZAP scanner itself. So the high-risk vulnerabilities really need some urgent attention here, while medium and low indicate moderate to minor issues. Informational findings help improve overall security awareness. So let me start with some of the high-risk one, or something to highlight here. So we have CWE 79. Which is a number given to each vulnerability that has been found. This is nothing but which is called the cross-site scripting, which is XSS. It's basically a vulnerability that occurs when an application does not properly neutralize untrusted input during web page generation. And this can allow attackers to inject malicious script that can execute in users' browser itself. And such attacks can lead to theft of sensitive data, like, again, user credentials, even allow the attacker to impersonate the user itself. The most frequent vulnerabilities that was common in all 5 CAD tools was something called header not set. And this comes with a vulnerability ID that's 693. This, again, means or refers to missing or improperly configure HTTP headers that are critical for security web application itself. It's, again, closely related that are missing to anti-clickjacking headers and the absence of HTTP strict layer itself. So all 5 of these CAD tools, CAD websites, they are not are following this particular protocol itself. So to conclude, again, we have identified 25 unique vulnerabilities across 5 CAD tools, and as I have mentioned, we have the 2 most common vulnerability that is 79 and the one for HTTP security headers. These findings highlight that the urgent need to improve the security of these CAD tools, especially given the growing importance of CAD in the AECO industry itself. Looking ahead for our future work, we'll explore AI-driven security tools to enhance vulnerability detection and classification. Further, also, we aim to investigate effective mitigation strategies such as automated patching and improve secure score practices. So it's, as we wrap up, it's really critical to emphasize the importance of prioritizing security today to safeguard all of the innovations and all of the works that we do. Along with that, also the data has to be secured. So in the context of open source CAT tools, vulnerabilities can lead to serious consequences. So from data theft to data manipulation to disruption of your design itself. So for industries like, again, AECO, where digital collaboration and design integrity are really paramount, these risks could translate into costly project delays, loss of intellectual property, or also even damage the reputation of that company itself. So taking proactive security measures now helps prevent these outcomes and build the trust in your the tools that you pretty much use on a day-to-day basis. This slide just, again, lists the references that we have used for this presentation. And I think, yeah, this is it. So do you have any questions?